In this video, we're going to be talking about Module 1, integers, fractions, and decimals, and we're going to start with the absolute value. The absolute value of a number is the number's distance from 0 on the number line. So to visualize this, we have a number line, 0, right? 0, 1, 2, 3, 4, 0, and then -1, -2, -3, -4. So if we were given, let's say, the number 3, where is the number 3 on our number line? Well, it's right here, right? And if we count from 0, we go 1, 2, 3 places. So the absolute value of 3 is 3. Because it's a distance from 0 on a number line. Okay, -3 is over here. And how far is it from 0? 1, 2, 3. So the absolute value of -3 is also equal to 3 because we're talking about a distance. So that is why the absolute value of a number is always 0 or positive. It cannot be negative because it's a distance. You can't go a negative distance. It's how far from 0 is the number they gave us. So looking at number 1, it says the absolute value of 15. Using this idea, how far from 0 is 15? It's 15. -18. On a number line, how far is -18 from 0? It is 18 places. And now it says negative absolute value of -35. So I want you to think about this kind of as two separate parts. So we're going to start with this piece inside the absolute value, and we're going to kind of ignore that negative that's out front, okay? So think about the absolute value of -35. How far is -35 from 0 on the number line? Well, that would be 35, right? This negative out front is kind of like a -1 times the absolute value. So if we did -1 times 35, it would give us a negative in our answer. So even though the absolute value itself, the part in the blue circle, cannot equal a negative number, this negative out front makes it a negative answer. So the next part here says two numbers that are the same distance from 0 on the number line but are on opposite sides of 0 are called opposites. Okay, so we could look at our original example up here where we had -3 and 3. Remember, their distances, their absolute values, were both equal to 3. They were the same distance from 0, but they're on opposite sides of the 0. One was positive, one was negative. They are called opposites of each other. So using this line of thought, the opposite of 9 is -9. And the opposite of -13 would be 13. To add two numbers with the same sign, add their absolute values and use their common sign as the sign of the sum. So our first problem here is -4 plus a -1. And I want you to think about this like they're going the same direction. So if we go back to the number line, okay, all right, so we had -4, right? We're starting at -4. And we want to add a -1. We want to add a -1, so we want to go more negative. Put it in a way that is relatable for you, that makes sense for you. So I use money. -4. So if I owe you $4 and I come back and I borrow another $1 because I'm minusing another $1, I did not pay you back. I owe you more money. So I'm going more negative. So my answer would be -5. Using what they say in the line here, you could take the absolute value of -4 is 4. Absolute value of -1 is 1. 4 plus 1 equals 5. And you use the sign from both numbers. Either method is okay. It's just what makes sense to you. A -2 plus a -21. Again, they're the same sign, so I'm saying I'm borrowing more money. I'm going more negative. If I use the absolute value of -2 would be 2, and the absolute value of -21 would be 21. If I add those two, I get 23, and their signs were negative, so it's a -23. And that makes sense because they were the same, and I'm going more negative. To add two numbers with different signs, you find the larger absolute value minus the smaller absolute value and use the sign of the number with the larger absolute value as the sign of the sum. Okay, so we're going to look at, when you're doing subtraction, and when they're different sides, you're doing subtraction, you're not adding. You always want to subtract the smaller number from the larger number. So that's what they're saying with the absolute value. So -7 absolute value would be 7. 6 absolute value would be 6. So I want to do 7 minus 6. Even though the negative is on the 7, we can't take 7 away from 6. Again, if you think about it in a way that makes sense to you, so think about money. If I'm at the store and I have $6 and I want to buy something for $7, how much do I need? What am I short? $1. So if I use the same idea but with the absolute value, I do 7 minus 6, because you do the larger absolute value minus the smaller absolute value. 7 minus 6 gives me 1. And then you use the sign of the number with the larger absolute value. In our case, it was the 7. So it's a -1, which makes sense because we use the idea with the money, right? Here, the absolute value of 14 would just be 14. The absolute value of -8 is 8. So which one is larger? The 14. I'm going to do 14 minus 8, right? Which gives us 6. And then we look at the sign of the number with the larger absolute value, which was 14. It was positive, so it is +6. Going back to the money idea, if I have $14 and I spend 8, I have 6 left over. I still have money. I didn't spend all of my money. To subtract two numbers, add the first number to the opposite of the second number. And what they're saying is make this a -3 plus, and we had a -2, so the opposite of -2 is 2. And now do the subtraction or addition as needed. If that is difficult for you to remember, there are more than one way to remember this. Some people like to think about, if I have a negative next to a negative, I say that it is not negative, therefore it is positive. The sign in front of the first number does not change. Only when you have a negative directly next to a negative, we say it's not negative, it's positive. Or some people like to just make these two into a plus sign when it's right next to each other. If they're not right next to each other, this rule doesn't work. So using this, -3 plus 2, okay, I have $2 and I want to spend 3. I'm short 1, right? But we use the absolute value of -3 would be 3. Absolute value of 2 would be 2, so -2 gives me a 1. Use the sign of the larger absolute value, which was a -1. 2 minus 8. So this one's just 2 minus 8. But if we use this opposite of the second number, we would have 2 plus, we add, what is the opposite of 8? negative 8. So you'll see it written like this a lot of times in the videos on my math lab. You do the same thing as we did above, right? We're going to do the absolute value of each one. Absolute value of negative 8 would be a positive 8. Absolute value of 2 is 2, so we're going to do minus 2. 8 minus 2 gives me a 6. Take the sign of the larger absolute value, which would be our 8, so it's negative 6. Okay, again, using money. If I have $2 and I want to spend 8, do I have enough? Do I not have enough? Hopefully you said I don't have enough. I'm short $6. I'm negative $6. 15 minus a negative 11. So again, you can say 15 and then it's not negative 11. So it would be 15 plus 11. Or you can use the opposite where we say that 15 stays as it is. The first number stays. And then you add the opposite of this number. So negative 11, the opposite would be 11. So you get to the same thing. And all we have to do here is add. So we get 26. Because they have the same sign. To get the product or quotient of two numbers with the same sign is a positive, always. So whether they're both negative or they're both positive, it's going to be a positive. And then the product or quotient of two numbers with different signs is a negative number. A positive times a positive is a positive. A negative times a negative is a positive. A negative times a positive is where you would get a negative. So here, when you have multiplication, you just work left to right because it's all multiplication in between. So I can say negative 7 times a positive 4 gives me a negative 28 times a negative 2. And the same sign times each other will be positive. A negative times a negative would give me a positive 56. Okay? Negative 9 squared. And so squared, the exponent means something times itself. So if it was just a positive 9 squared, it would be 9 times 9. Okay? Since this one says negative 9 squared, you have to be careful with this because what this is saying is the opposite of 9 squared. It's not saying negative 9 squared. So it's more like negative 9 squared, even though they don't write it that way, which would be equal to a negative of 9 times 9. We said 9 times 9 was 81, so this answer is a negative 81. Versus number 15 that has it in parentheses. See, this says a negative 9 squared. So this says negative 9 times negative 9. Well, negative times a negative gives me a positive, so this would be a positive 81. And you don't really need the parentheses there. It was already in parentheses, so I wrote it again. But you could write it as 81 like that. Okay? Last one says negative 20 divided by 4. So 4 goes into a negative 20. And when you do long division, right, we think what times 4 would give me a negative 20? Well, it has to be a negative number because 4 is positive. So you would get negative, and 4 times 5 gives me 20, so the answer would be a negative 5. Okay, dividing by 0. So you can see here at the top, they give us this little sort of hint. It's very important. So 0 divided by n equals 0 divided by n, which equals 0. And we say that it's on, or it's okay, because the 0 is in the numerator. When it's in the denominator, we say n divided by 0, or no. N divided by 0, no, is undefined when the 0 is in the denominator. The other way I want you to think about this, and I'll just use my 0 divided by 5, if I set up the division, right? If I go ahead and divide, I put my second number outside and my first number in, right? That's how you set it up into long division. Well, what times 5 can give me 0? 0, right? 0 times anything is 0. So 0 times 5 would be 0, and the answer is 0, okay? Now, if I do the same thing here, the second number goes outside and the first number goes under. Well, what times 0 can give me 5? Hopefully you're saying that's not possible because we just said that anything times 0 equals 0. So the only thing I can get here is 0 because I'm going to multiply it by 0. And this would be undefined. So whether you remember that it's on or no, or if you set up the division and try to use logic, if the 0 is in the numerator, it's 0. If the 0 is in the denominator, the bottom part of the fraction, it is undefined.